Hello, this is Daryl Korn, and this is my homework 4 presentation. So let's get into it. We will start with the code, as always. So for my embedding layer, this is my code for my model with an embedding layer. Um, we start by bringing in the Python packages, and then we import our data from Kaggle here. And then here we want to transform our data a bit before putting it into our model. So we start by encoding our dependent variable. We always want to encode it because neural networks like numbers more than they do letters, unfortunately. And then we tokenize our training data. We start that by creating our tokenizer and including the out of vocabulary token. We fit it on the text, and then we turn our text into sequences here. So then here we set our max length of our sequences to 30, and then we pad those that are under 30. And then we create our training and test data here. And then we create our training and validation data out of our training data here. Now here we define our early stopping metric for training the data. We want to monitor the validation loss, and after 15 epochs, if it has not improved or if it's worsened, then we stop the training and we restore our best weights. And I found that this best weights restoration really helped improve some of my models. Now for compiling the model, it's the same as my best model from homework 3, which apart from adding this embedding layer here that is maxed at 100 dimension vectors, we have 4 LSTM layers, 2 dropout layers, or 2 dense layers, sorry, no dropout layers, those are commented out, and L2 regularization, as well as a learning rate of 0.001. And then here we fit our model, and then we evaluate it on some test data. So there's all that good stuff. And lastly, we display how our model did right here. Okay. Onto the glove pre-trained weights. So very similar, not as much to go over, although I did create my own download function here to streamline things. Here we bring in the downloaded embeddings, and we're using the 100 dimension content right there. And then, of course, bring in our Kaggle data, and all this is pretty similar, except we fill the embedding matrix down here using the code given during one of the labs. Still create the training and test data as usual. And then we define the same early stopping by monitoring the validation loss. And then for our model, it's pretty much the same, except we load our pre-trained weights right here, and we're able to set these to trainable or not trainable right here. Okay, then we fit the model and display our training metrics down here, just like before. Okay, on to the analysis then. So first up, I'll just go over what my best model was from homework 3. The structure of that model was 4 LSTM layers and 2 dense layers. No dropout layers. I did not find that those helped the model at all. I also included some L2 regularization, so there's a little bit of data augmentation, and my learning rate was 0.001. Also, I included some early stopping by monitoring the validation loss and then restoring the best weights. And I found, after running 4 tests and averaging my results, that here's some example training and validation accuracies, as well as the training and validation loss, that the model overfit rather quickly after like 2 or 3 epochs. But the average test accuracy was 76.3%. So yeah, success is relative, I suppose. Okay, that's what we're comparing against. Let's go on to the embedding layer. So for this, once again, my embedding layer, we fix it to 100 dimension vectors. Same layers as previous model, same early stopping mechanics. And the model still overfit rather quickly, although I guess it took a little bit longer on average, maybe like 3 or 4 epochs. It's hard to say that's a significant improvement though. And the test accuracy after running 4 different tests was actually a little bit lower at 74%, which is interesting. Okay, on to our glove pre-trained weights. So the embedding layer is still fixed to 100 dimension vectors and same early stopping mechanics. Um, I found after running some tests that allowing the weights to be trainable caused the model to overfit quicker. So you can see here in figures 3.2 and 3.4 that we are running for less epochs as opposed to 3.1 and 3.3, where the weights are not trainable, and those went for longer epochs, as we can see. So they were fitting a bit quicker when the weights are trainable. And I suppose a bit reflected in the average test accuracies as well, because the weights were not trainable, we had a slightly higher um, score on the test data at 79.2%, whereas when the weights were trainable, it's only 78.3%. So slightly better when we cannot touch the pre-trained weights. Okay, time to sum it all up. We found overall that the best model on this data was the glove with untrainable weights at 79.2% accuracy on the test data on average. We also found that implementing that early stopping technique and then restoring the best weights helped improve a lot of the scores. So that was a better method for me than trying to go back manually and set the epochs. It was just easier to let it kind of find what the best weights were. Um, I thought it was interesting that the embedding layer performed worse in the LSTM one-hot encoding model. Um, embedding layer model, that is. I really expected the embedding layer model to do better, but I suppose there was something about one-hot encoding that um, that data was just more predisposed to. Or it was that my embedding layer just couldn't quite get to the level that it needed to because the pre-trained embedding layer through Glove did perform better than the LSTM model. So maybe that had something to do with it. And both Glove models perform better, whether I could fine tune the weights or not. Lastly, I thought it was interesting that the Glove model where overfit quicker when I allowed the weights to be trainable. So I suppose something about keeping those weights untrainable, um, the LSTM layers had a harder time memorizing the data and therefore overfit less quickly. But I think that also led me to my best test accuracy. So that concludes homework 4 for me. Thank you very much.